We are here at the ORNL Molten Salt Reactor Workshop 2018. I'm Thomas Pedersen. I'm from Copenhagen Atomics, one of the molten salt reactor startup companies. Around 250 people in total interested in molten salt reactors. And we all hope that we can move this field forward.
I'm having visa issues, so maybe you guys could talk right where you were. I don't think it'll go badly, but if you guys are having
Is it the same, the tourist visa thing? Or?
Yeah.
Yeah,
So
we had the same problem.
Just do exactly what you're doing.
How long can they run for?
Well, they'll just keep going, but when you're done, turn them off, okay? So we don't
It's just to explain.
Why do
So
you have to go to Knoxville? There's a site office.
I don't know. I got a stamp in my passport saying business visa, and he got a stamp saying tourist visa, and we didn't care to ask. We didn't know. They just stamped it, right? It's this loop. It's on a pallet, so you can move it around.
Yeah.
And it basically in here you just have a tank down here with the salt, and then the pump, and then you can just pump it around, and then you can add different tests on that. You can even take the pipes out. We want to take the pipes out inside a glove box and come back. Okay. We haven't done that yet, but
is it for just heat transfer, or
it's for
corrosion?
Yeah, for testing pumps and valves and measurement equipment. We have a LIPS measurement system where you can use laser-induced breakdown spectroscopy, to measure the different isotopes in the salt while it's pumping around.
Oh, okay.
And we need to, that we want to make that into a commercial product that other people can use for reactors.
Good.
And we can use it ourselves as well. But in order to get that to a level where it's a commercial product, we need to do lots of testing on molten salt while it's circulating. So that's part of the reason why we built a loop.
would that be fluoride and chloride?
Yeah. So we can make measurements every second, for example. So it helps you a lot if while you're running the reactor, every second you get a profile of all the different isotopes you have in the reactor, and you can see how that changes over time. So you can detect if there's plate out or corrosion or some of the components are wearing down.
Are you also looking at being able to look at thorium fuel cycle?
Yeah, definitely. We are a big fan of the thorium fuel cycle.
Good.
So we think that the thorium fuel cycle creates a lot less waste, and it is able to scale to a large amount of energy output.
Yeah. Well, that's going to be my pitch at the Belgian meeting. I'm not allowed to talk about thorium here
Okay. Okay.
because Lou said, "Don't go off on one of your rants."
Okay. Yeah. The whole point of your team back then was to let's build it with uranium first, make sure it works, and then let's run it with thorium later.
Oh, yeah,
but then you never got to run it. That's really sad.
Yeah, it is. But
Sorry, can I move you? I'm sorry.
We need to go back a little bit further.
Let's make sure I'm wide enough so you both. Okay, continue. That's perfect.
I actually,
Is that okay?
Yeah, you can ask questions.
Yeah, I have a question. Could you talk a little about what was the atmosphere of innovation back then? How, when you were working on the MSRE, what was the innovation cycle, troubleshooting, what was the approach to engineering the MSRE?
Oh, approach to engineering. Well, we were much more limited with the technology, the equipment that we were given to do analysis, and it's been quite a change in the last 60 years.
Today, in the light water reactor industry, if you want to change something, oftentimes they say it's going to take 10 years to change it.
Oh.
But we have a clear understanding from all the different reactor designs that were back in the 60s and 50s that the cycle time between you found out that you wanted to change something till you actually change it was more like a month, not years, and definitely not decades.
In the case of the MSRE, if we wanted to change something, we'd write up a little, let's do this, and it would go up the line, not too far. I mean, Dick Engel and Paul Habenrich maybe, and they'd sign off on it, and we'd do it.
Yeah.
It's not, it was very different back then.
That's also kind of what we get from the videos from back then when we see videos about how things were built. And I think some of the things we do today are put too much constraints on what people can do, so the progress is too slow. But of course, we also have to be responsible and safe.
And some other isotopes have horrible gammas.
Yeah.
The maintenance could be a real problem, except that we've got robotics now.
Yeah.
And as long as the robotics are hardened so that they can stand the gamma. That's something that can help solve the problem.
Yes.
So I'm pretty sure that there's enough new technology and things like that can solve these extra problems you're going to get into with the thorium someday.
That was a great question. We have Uri Gat here. I didn't know this was Uri Gat. I just put microphones on Uri Gat.
Oh, the guy with the short pants?
I don't know what anyone looks like. You're the only guy I know here.
Join in the video.
Your great hair.
Always behind.
Yeah.
Even on the side, it said no.
Okay.
Did you get your Knoxville thing settled?
No, I have to go away. Just keep doing what you guys are doing. It's great. Yeah, just continue. Go introduce. Like, I can't
Yuri,
hear
if you can explain your role in the whole thing in the 60s.
Let me ask Syd a question first.
Yes.
Did you work on the design of the MSRE?
Yes.
Okay, then you have been longer on molten salt than I have been.
Well,
I started out in Germany in 1963, and we worked. A guy from here by the name of Paul Kasten came over and led the Institute of Reactor Development in Germany, in Jülich, and brought the molten salt. And at that time, the idea was you had to have a breeder.
Yes.
So we went to an epithermal molten salt reactor, which is can be a better breeder.
Yes.
And that was how I got involved. The name of the reactor was Mosel, after the Mosel River, but it's molten salt epithermal. And we were always very proud of the name of it.
Yeah.
And then it was discontinued, the program. I heard you mentioning that you worked on HTGRs. I worked on HTGRs on the what they call the Kartoffelhaufen reactor, potato heap reactor,
Yes.
because it was made out of spheres of graphite. And then I came to the United States, and first was 5 years in Kentucky at the faculty on University of Kentucky, and then I came down here.
I didn't know you were from Kentucky. Your accent.
I'm a Kentucky.
Your accent.
I'm a hillbilly from Kentucky.
Okay.
The Molten Salt Reactor Mosel experiment in Germany, was it ever turned
You
on?
speak German?
Not on video, but I understand German fairly well, but if I need to be in Germany for 1 week before I can start speaking any.
What's your accent?
I'm from Denmark. The Molten Salt Reactor in Germany, was it ever turned on, or?
No, it wasn't. It wasn't even built.
It was not built, just this
Not
design work.
even got in. It didn't come even close to the stage of building.
If I remember correctly, there was some pebble bed reactor later
There
on.
there are two pebble bed reactors.
Yeah.
One is the AVR, which was built while I was in Germany. It went critical while I was there. And my office was across the street from the reactor.
It's a German word, about that long.
Atomversuchsreaktor, experimental reactor.
Yes, yes.
And then it was a THTR, which is power reactor.
Say again?
How well do you two know each other?
Oh, we've worked together for, what, 50 years? I met him when he first came in on the gas cool reactor project, and I was on it then when he came in.
So did you guys both know Richard then? Richard Engel?
Oh, yeah. Well, Dick didn't work on the gas reactor as far as I
Yeah.
know.
So the gas reactor is after the molten salt reactor started.
yeah.
So you guys met after the molten salt reactor.
We worked on the gas-cooled fast reactor, GCFR, that was at that time, again, a breeder reactor competing with the LMFBR, and the CRBR was being built at that time until they discontinued it. And he helped with everything. Everything I know from Syd, because he did the calculations whenever I needed.
I didn't do much with the GCFR, the fast reactor. I thought that was an accident waiting to happen, and
Okay.
I just didn't like accidents. One of the nice things I like about these advanced reactors, that both the molten salt and the modular HTGR gas cooled, is that they don't have accidents. They don't have really bad accidents.
That's people always ask me, what is the worst thing that can happen? Maybe you guys can explain, like, what is your, like, worst case scenario with a molten salt reactor? like if somebody shoots a missile at it, or you know what?
Even that wouldn't be that terrible.
No, it would not be like Fukushima.
It is the opposite of other reactors. You have to understand it's a liquid fuel.
Yes.
And if it bursts, what is a meltdown in other reactors, it freezes because it's running at a high temperature, and when it goes off, it becomes subcritical, it freezes. And all you need is theoretically three things: a pot, a pipe, and a pump. But somebody who worked with me added in a force-P a pen to collect that what leaks out and freezes down there. And all you need is put a new vessel and pump it back in, and you run it again.
One of the major problems, I think, would be if the stuff started freezing in the pipes.
Yeah.
Piping system.
But it's not an accident. It's just then maybe if you cannot heat it up again in the pipe, then you have to.
A real pain in the ass to get it going again.
Yeah, that's true. Yeah. But it's not an accident.
I never did any thorough investigation of that, but I wouldn't think it would be that much of a safety problem.
No.
Because it is such a self-negative reactivity with temperature, there's a cold plug accident. If you start a pump from a source where the salt is cold and you pump it into the reactor, you get a reactivity jump. That can be one that you have to deal with, but it's not as serious as with other reactors.
If you do that and you get a rupture of a vessel or something and you spill out the salt, then that's, of course, you basically broke your reactor. But again, you don't get radioactive elements into the environment and the neighborhood.
We simulated a lot of those cold slug accidents, and it didn't amount to any real safety problem. No. Now, I don't know if we simulated the absolute worst case, because you can dream up things that are pretty much non-physical. That was one of the things that caused me to worry about any of these things getting through our licensing. Because when I worked on the HTGR a lot, yes, with the NRC, they would always dream up something else because they couldn't find any reasonable thing to make it a safety problem.
Yes.
And so rather than having them say, "Oh, great, this is a safe reactor, we can get the licensing going," they just had trouble wrapping around that. And once we got these guys ready to, oh yeah, I think I understand, they moved to another division and they got new guys coming in, okay, starting over again. When I was working with my Japanese buddies, I said, how come you guys get an experiment going? They had some really nice experiments going. The HTGR was a good guess, Gord. I don't think they ever got a molten salt thing going, but they would work on that and fund it and have all sorts of great experiments and things. And I said, how can you keep that thing going? And they said, well, you know, we don't have coal supplies or other options. We need the power, and so we've got to work on this stuff. So yeah, that hasn't been our problem. But now we've got the global warming thing.
Fluid fuel reactors are fundamentally different from solid fuel reactors. And that's what Syd explained. Educating the licensed people who have to give you the license is a terrible work. You have to start from scratch and to go through the entire development. And that's what's the problem, and they don't last long enough.
Global warming is going to do really bad things, like cause populations to have to move. Yeah. Millions of people.
We need to bring a better way of living to people wherever they are, and one way of bringing a better way of living is energy. I mean, energy is one of the fundamental things that needs to be there.
Energy and water.
Yeah.
Okay, I worked on the nuclear desalination program for a while.
Yes.
And that was a neat program. And we worked with the idea of trying to get the Middle East people to work jointly on getting water. Well, Uri's from Israel, and he knows what.
Yeah, that's water is also important.
For not having enough water.
bring reactors to Sinai and make it a refugee peninsula. The reactors will bring energy and desalination, and it'll be a blooming place for all kinds of, and there was very little population.
Because it's easy to take the discussion that we all think that climate change is a problem and we should solve that and we should all use less energy. But when you start to ask people, nobody wants to use less energy. Population in the world is growing really fast. I think it's 80 million people every year. So it's the entire population of Germany we add to the global population every year.
Even if you didn't have the increase in world population, you'd have the underclass people, the people who are in third world countries, getting more and more developed, and their demand for energy goes up.
I think the only thing that can make me use less if it was more expensive, because it's not only me. I mean, if I look at all the other people I know in society, nobody wants to use less.
How are you going to push that politically in the United States?
Yeah, that's it's very impossible. That's basically why we are doing this molten salt reactor thing. It's because we have a strong belief that this is one of the ways we can create twice as much energy in the world, and that will help solve some of those problems. But I'm also a little bit afraid that if we create a lot more additional energy, maybe people will start to have 3 kids instead of 2, and then we didn't solve anything.
Well, I think it tends to go the other way. The more affluent people get, the fewer kids they have. Late night television is a great way of cutting down on that. Most people in the bad shape right now don't have the flexibility and the resources you do to solve a problem for you. I mean, you don't have a problem.
That's true. I have enough free resources that I can work on this. And it would make a lot of sense if we can make it work. I don't have enough money to build a full reactor. I would need support from other people, but I can take some of the first steps.
You need the reactors to solve the CO2 problem. Without solving the CO2 problem, you don't solve the climate change problem. Without solving the climate change problem, you don't solve any problem.
The kinds of things that can happen can be catastrophic. They call them tipping points.
Yes.
You're familiar with the tipping points. Yeah, like if it gets really bad like that, huge dislocations in populations can,
That can create wars.
Cause a war, yeah, sure. This crazy country that you're in right now decided to increase the military budget by, it was either 60 billion or 80 billion over the last 2 years, depending on which you read.
Yeah.
Okay.
Give me 1% of that, we can build in molten salt reactors.
That's exactly my point. A real aggressive molten salt, thorium cycle, you could solve these problems and get something running fast.
Yeah.
Now, if you look at the things that a well-developed thorium cycle machine could do, you can take care of the global warming thing. This takes a while.
Yeah, of course,
but and you could get people to be more relaxed about their resources. We wouldn't have to invade Iraq.
fight over oil and gas.
Yeah. Reduce the chances of war and have sensible people in charge. You'd cut back on all that expense, put it into energy development, clean energy development. After our meltdown in 2007, 2008, a year after that, Goldman Sachs gave their workers total $16 billion.
Yes.
16, yeah. Okay, $16 billion. If a third of that were put into solving problems.
Yeah.
I mean, money, they say, oh, these reactors are too expensive. Well, they don't account for the external costs, like pollution, or wars, etc., or global warming.
Yeah.
So,
So we've talked to a number of investors, and my feeling that there's enough money out there. The problem is not money, the problem is risk, because the investor sees if they put money into something, there's somebody else who can make a decision that it won't happen. Like you will not be allowed to turn on the reactor. You can build the whole thing, but you will not be allowed to turn it on. And somebody else has the power to make that happen. So the investor is not afraid of the technology. He's afraid of what other people might do to stop the progress.
I got involved with the Green Party. A good friend of mine was a character in the U.S. Green Party. And so I got arguing with some of their top drawer type guys. And they're going on the LNT, the linear no threshold idea, that one guy said, for every millirem that you nuclear guy produces, you're killing a baby.
What?
Yeah. If you multiply the very low probability by millions of people, which is what LNT does, you're killing babies.
But did you tell him about radioactivity in coal ash or in bananas or?
I tried everything. I mean, the simplest thing that seems to work with some people is the people in Denver who get 400 millirem per year instead of 200.
They should be dying like flies.
Well, they should at least have a noticeable increase. They don't.
No.
Okay, and there's some medical studies that were done recently that follow the actual process that happens when you get low doses. If you get low doses and time it tends to repair itself. The Fukushima accident, for example, some people were saying, because of the radiation, so many thousands of people are going to die from it. Well, the doses that were gotten by everybody, including the guys that went into the plant to try to turn the valves, open the valves, they didn't get enough to affect their cancer probabilities. The reason I wanted to get the Green Party involved is if we could get them on board and say nuclear is green, that'd be a heck of a good thing, especially in a place like Germany where the Green Party is essential to their coalition. You may know about that. They're about 6% or something, and the group in power needs them as part of their coalition. If you could convince these guys about this LNT thing, you could. Well, Germany, they've gone apeshit about the shutting down their reactors.
They're still shutting down their reactors. Unfortunately.
Yeah, but don't you think maybe at some point it will reverse? Like in Japan, they also after Fukushima.
Convinced it will reverse. The only question is when and how much damage will have been done by then. How much of these last hurricanes is due to the climate change and how much the severity. And you can't prove some of these things, and so those extreme other guys can always claim that it's not related.
We would really like to build a lot of these molten salt reactors and put them everywhere in the world where people are, so they can get a better life. So let's say we build a number of these already and it turns out to work well. How do you feel about putting one of these in some Africa country where maybe there's not a super stable government? Do you feel that would be an awful thing to do, or you think it can be managed? If there's like when we have war zones, there's UN troops with these blue helmets as observers. Maybe we could have similar thing. You could allow people in an unstable region of the world, put a reactor there, but have international inspectors come there and make sure that everything is going on okay. Do you think that would be safe, or do you think this would be unsafe to put nuclear reactors in countries like that?
Depends a whole lot on the local situation and how much they could pretty much guarantee that they wouldn't try to blow it up.
But even if they blow it up, we kind of agree that we won't kill any people. Of course, the cost of that one will be lost.
Dick Engel had a reactor that I call the Sealed Reactor, in which he would send a complete reactor to any place, including those that are problematic, and it'll be sealed for 20 years, and after 20 years somebody will come in and change.
Take it back.
There's also concepts of very safe molten salt reactors that you cannot divert enough fuel from them without knowing about it. But it's always a problem, and just the idea that it can happen is one that has to be dealt with. But molten salt reactors are, I dare say, the safest reactors there are. You could conceive of a reactor that barely works that is safer, but...
Well, when you get involved with the politics, though, it's hard to say. I mean, even if somebody blew it up and it didn't contaminate the rest of the place, it'd be huge news. And reactor, radiation, blah, blah, scheduled to go to Japan to help them with their reactor. And I had all the work figured out, and I was almost getting on the plane, and that criticality accident in Nara happened. I think 2 or 3 people were killed. They canceled my trip. Yeah. But they had people sheltering in place, 20-minute train ride from that place, which, the exposed area was a few hundred meters. And it got all over the world. Japan's worst nuclear accident, and 3 people died. The same week, there was a spill of a hydro dam in Africa that killed 300 people. Yeah. And that didn't make the newspaper. Even if you convince 90% of the people that this LNT is a bunch of crap, the news about nuclear problems would be terrible.
Molten salt reactors have another advantage. They can burn the fuel that's used for bombs in a very safe way, and get totally rid of it, and in a useful way, because it'll produce energy while it does it. There are very few other concepts that can do that.
Well, the storage of spent fuel is so much easier with the molten salt, especially with the, as I understand it, the chloride is even better than the fluoride. I don't.
It's a little bit easier to convert the spent nuclear fuel rods into chloride salts and get it going in a fast reactor. But from my experience, I think we can also do that into fluorides and use it in thermal spectrum reactors.
Okay.
But there's rumors that because of some decisions in the 70s here in the US, that the US will not allow us to do reprocessing of spent nuclear fuel anywhere in the world. I don't know if that's just rumors or if it's really true, and I think this is some of the things we need to test. I talked to people from Canada on Monday, and they said, but you can likely be allowed to do this here in Canada. Mm-hmm. So, once you start to do it in some countries, Canada can do it, Russia can do it, China can do it. I don't know who else can do it, but once you start to be doing the thing there, then hopefully also here in the US it'll happen, and in several of the other European countries. Mm-hmm. But we need to get started on that because most politicians don't know. They think the waste problem from nuclear reactors cannot be solved. They don't know that you can burn it again and make it a lot less waste.
Or you could just store it in a safe place.
It's not much, it's very little.
Yeah, but they see it as a big problem, and in my country we don't even have spent fuel. We have just waste from medical hospitals and stuff, and low-level radioactive, and they are discussing like crazy where to put that. And I'm like, the coal ash has also radioactivity, but the population doesn't know that, so they don't debate it. They just put it right in the middle of Copenhagen.
Oh, really? Oh, we've had some really bad coal spills.
How did you get involved in that molten salt?
Okay, my background is in software engineering and mathematical modeling, and I've done a lot of technology-related startups, and basically worked with new technology my whole life. And then I've been interested in energy production for many years for some of the reasons we discussed earlier, I started to hear about this thorium entity. I've never heard about it before.
Yeah.
And the first couple of times I read about it on the internet, I was like, nah, it can't be true. It's got, you know, it's got to be one of these.
Was it Kirk Sorensen's?
I think one of the first stories was not by Kirk. It was like a news article somewhere. But maybe that one was inspired by Kirk. I don't know.
Yeah.
But eventually I got around to see some of Kirk's videos and his TED Talk really early on. And it was right around the time when I saw some of those first videos. I thought, I got to figure out what's wrong here. I mean, I got to figure. I'm sure there was some error they just hadn't told me about. So I started researching. You know, what is the error? Oh. Now it's lunch.